Soft robot, by definition, is a robot made of things that are not rigid or not hard. We make robotic actuators out of rubber materials. No sensors, no tendons, no pulleys, no rigid joints. If you think about if you were going to build a robotic octopus, what would it look like? That was the inspiration for our technology.
Can you break down the technology on a really basic level as far as the inflation, how it actually works?
Great. So basically we take elastomeric material, so rubber, build a number of fluidic channels into it, layer it with composites, so other materials of other stiffness, and then by controlling the pressurization, the rate of pressurization, you get bending or extension or actuating. And so if you think about inflating a balloon, it inflates outwardly. With a soft robotic actuator, because you've built these layered composites and you've channeled the air in a certain way, you can get this gripping action instead of just an inflation, you get actuation.
And why is this better than a hard robotic hand?
Well, the best part is if you think about a traditional robot hand and you think about picking something up, it has to know exactly how to position. So it has to know the exact location of the object. It has to calculate its path. So there's a lot of numerical computation. And then there's sensors on those fingers. So it has to grasp that just enough, but not too much. So a lot of processing can be very slow, very tedious to solve this. What we've done is we've said, if you have a hand like a human hand, but it's made of rubber, it can just grab anything. And so that's what we do is we use very simple vision systems. We do very little grasp planning, usually just aligning on the long axis to orient something in a package, and you just grab it. And one of the questions we always get asked is, how does the robot know that you've changed the objects? It doesn't know, and it doesn't need to know. All of the material science and the hand and the actuators allow it to conform to any object.
So it's a relatively new technology?
It is. It's been in the academic lab for some time. We actually spun out of George Whiteside's lab at Harvard. He started this work in 2008, 2009 under a DARPA contract. We started looking at it in 2012, and in 2013 we decided it was mature enough to really bring out, put into an entity with a focus on commercialization.
So now 5 years later, these are actually out in the world?
Started the company in July 2013, spent the first year trying to solve those two big problems, and really started selling late 2015. And these are out in the world in manufacturing environments today, everything from injection molding to assembling drinking cups to packaging bakery items.
Are these taking jobs away from people?
So what we're doing primarily in packaging is there's a labor shortage there. So we're working with customers in the food industry where they don't have enough people to staff their factories. And so it's not, how do I squeeze another bit of productivity out of my factory? It's how do I keep my factory running so I know I can supply product? And so a lot of these firms, they have temporary labor constantly coming and going. You think about training, the quality, all of those challenges. And so what we're looking to automate are things like packaging dough in a 40-degree warehouse. It's not a good job, it has high turnover. Or working in a high care area, or even some environments where people are packaging things in freezers. So you're in a -20 freezer hand packing. So not jobs that people want, addressing the acute labor shortage.